Start streaming. So we're going to talk about our circulatory system. And talking about the circulatory system, load. Like normally you would not try to do both these in one day. That's a lot to do in a day. Hey, we're also going to talk about our blood after that. We're just going to talk about all kinds of things because life is crazy and COVID is nuts. But the whole point of the lungs is to get oxygen in the body, right? That's what we just talked about. And so air comes in through the nose, it goes down the trachea, it goes through the vocal cords, which we call the larynx, and then it makes its way down into the bronchi, the bronchioles, those split into the alveoli, and they put oxygen into our blood and they take CO2 out of our blood. Now, once we've done that, our job is to move that blood. Does that make sense? And that is the purpose of the circulatory system. The circulatory system is here. To move blood through the body. And the whole point of that is, of course, that blood carries stuff. All right, highly scientific language, I understand. But the circulatory system moves the blood through the body, and that's important because blood carries stuff and things. Things and stuff. All right, so we're going to go through this. We'll go through the presentation again, but then this time there is something to be filled out and to go with. All right? So the circulatory system is the system by which blood is moved throughout your body. This allows oxygen, nutrients, waste, messages, and all sorts of other things to be carried. So this is of note. Yes, it carries oxygen for us, but it doesn't just carry oxygen. It carries nutrients. So just like the blood goes to the lungs to carry oxygen around, it also goes to your intestinal tract. And it surrounds that small intestine. And when we absorb proteins and when we absorb sugars and all that stuff, it also gets carried in the blood. It carries waste in the blood. Even like your urine is release of like liquid waste, but even that is the blood being filtered through the kidneys, which becomes your urine, right? It carries messages. What kind of chemical in your body is a message that gets carried throughout your body and your blood? What do we call that? You're teenagers, so you'll be well acquainted with these. What do we call a chemical that gets carried in the blood that is used to tell your body to behave a certain way? There might be one in there that says, hey, get really energetic and amped up. There might be another one that says, like, just cool down. What do we call those? Hormones. You heard of that? Familiar term, yeah? So we can actually use our blood as a way to send messages all throughout the body. There's three main components of your circulatory system. There's the blood itself. The blood gets pumped by the heart. And, of course, you don't just have blood like floating all around your body. It's held inside of containers, right? Tubing, piping. We call those the blood vessels, all right? But just like, your toilet isn't hooked up to an empty pit. It's got tubing. It's got piping to carry waste away. The water that comes into your house doesn't just fall all over your house. That would be a disaster. You've got pipes and tubing that go all throughout your house, right? So that you can get it where you need it when you need it. Likewise, your blood. It's being pumped, but it's being pumped through tubing to go in a specific path through your body. Does that make sense? All right. There are three major places the blood goes to. All right? Basically, blood starts at the heart. I mean, you can think of it starting wherever you want, but just for simplicity's sake, it goes to the heart. The main purpose of the heart blood is oxygen. So we're going to think about oxygen as the way it goes. It starts at the heart, and if you think of it as a delivery system, if I work for Amazon and I'm going to deliver something to your house, first I've got to go get the thing, then I've got to bring it to you. Does that make sense? Like first I got to go to the warehouse, I got to pick up what did you buy? You bought a toothbrush. I got to go pick up your new toothbrush, then I got to bring it to you. Does that make sense? For the circulatory system, first the blood has to go get oxygen, then it has to give it to all the cells. So if it has to get oxygen first, where is it going to go first? Where does the blood get oxygen? The lungs. So, blood starts at the heart, then it goes to the lungs, and then it's going to go everywhere else. Does that make sense? We'll talk about how specifically it does that in a couple of minutes, but that's the basic pathway. So, this is kind of the loop. We have the arteries, the veins, the heart, and the lungs. And this is of note. We'll say this later, but probably a good thing to write this down a few times. If you want to type it in your notes somewhere, make a note, but this is important. Arteries carry blood away from the heart. This is really important. These names, and it's not just naming, they're really different vessels, and we'll talk about why that is. And veins carry blood to the heart. So when blood is leaving the heart, it's going in an artery. It gets pumped out. When blood is coming back to the heart, it's coming in a vein. Which one would be more dangerous to cut open, do you think? What do you think? We'll talk about it later. I'm not going to answer it right now, but get thinking about that. But here's the basic pathway. From the heart to the lungs. Hey, from the heart to the lungs, like this. This is leaving the heart. Is that an artery or vein? Artery. Good. We call that the pulmonary artery. Pulmonary means lungs. Hey, coming back to the heart from the lungs. Is that an artery or a vein? We call that the pulmonary vein. Yeah. Leaving the heart to go to the body. Is that an artery or a vein? Artery. Good. We call that one the aorta. It's a big, important one. And then coming back, there's a whole bunch of different veins that go back to the heart. Does that make sense? Cool. The heart itself, see I put a circle around it. The heart's a pump. It moves deoxygenated blood, that means blood that doesn't have oxygen, from the heart up to the lungs, and then it gets that blood back, now that's full of oxygen, and pumps it everywhere else. That's the heart's job. To the lungs, back, to the body and back. To the lungs and back, to the body and back. To the lungs and back, and to the body and back. Over and over and over again. Repeat, 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 repeat. Take blood, send it to the lungs to get oxygen. Bring it back. Send it to the body to deliver the oxygen. Bring it back. Send it to the lungs to get oxygen. Bring it back. Send it to the body to deliver the oxygen. Bring it back. That's what the heart does. Does that make sense? It's like the pizza shop. Come to the pizza shop, get the pizza. Get back in your car, go deliver the pizza. Get back in your car, go get pizza. Get back in your car, go deliver pizza. Does that make sense? The heart's the car, the lungs are the pizzeria, and the body, every cell in the body is a hungry person just waiting to get their pizza delivered. That was a C- analogy. That's not a very good analogy, but I came up with that on the spot. I'm going to give myself not a great mark for that, but that's okay. We know about the lungs. The lungs move air in and out of the body. That's where gas exchange happens. So that's where we get rid of CO2. That's where we get oxygen. We said arteries move blood away from the heart. So normally they either carry the blood that doesn't yet have oxygen to the lungs, and then later on they carry the blood that does have oxygen out to the rest of the body. They're always moving away from the heart. Veins, on the other hand, are always moving towards the heart. So they come back from the lungs with oxygen, but mostly they come back from the rest of the body without oxygen. If it's coming towards the heart, it's a vein. Leaving the heart, it's an artery. All right, this is worth mentioning. The heart is a pump, right? So something coming right out of a pump. Well, you can imagine this. If you open the spigot on, do you have like a hose pipe in your backyard? You have a hose, you know, for like water in the garden, or I don't know, like filling up a watering can or whatever. When you open that up, how's the water come out? Yeah, fast or slow?
Depends on how much you open the spigot.
Depends on how much you open it. You open it wide, fast or slow?
Fast.
Cool. Let's say you didn't open it. Let's say it sprung a leak. What's going to happen? Has that ever happened? Have you ever had a leak in a water pipe or a hose or something? Can you imagine if the water's on, but you know how you put the sprayer at the end of the hose? If you poked a hole in the water hose with the pressure on, what would it be like?
Just weaken the pressure and spray out.
It'd spray out, and it sprays out pretty hard. I've had that happen. I've had a hose split before, and it really comes out because it's under pressure. Coming out of the heart, the arteries are under pressure. Does that make sense? Whereas going back into the heart through the veins, the blood just kind of slowly makes its way back through the veins. Does that make sense? Now, if you're making a hose for high pressure, what's that hose going to be like? It's got to be thick, got to be strong, right? So the arteries are like that. If you look at them, the arteries are pretty big, and they're under high pressure. And because they're under high pressure, they have to be thick, big, thick, elastic walls. When the heart does a big pump, they need to actually be able to swell out a bit. Then they need to be able to contract back down when the heart's kind of between pumps. Does that kind of make sense? And they're always under pressure. The veins, on the other hand, nothing pumps the blood back to your heart. It's just kind of the blood behind it that keeps it moving. And so the pressure just drops and drops and drops as you go in the system. So by the time you get to the veins, the pressure is actually pretty low. So do you need big, thick, heavy walls in the veins? No, because the pressure is lower. Does that make sense? But you know what you do need? You do need... What's a valve? It opens and closes. And in your veins, there's actually valves. They're called one-way valves. I have something like this. I have a bar in my basement, and there's no drain there, so it has to be on a pump. So if you pour water in the sink there, it actually pumps it up to my laundry sink. But the result is we have a big pipe that actually pumps water away, and it has a valve in it that's a one-way valve. It'll let water out, but it won't let water back. Does that make sense? Our veins have to have that. They're under low enough pressure that if you didn't have valves, your blood would flow the wrong way sometimes. That would be bad, right? You don't want blood flowing the wrong way. So the veins are under low enough pressure that they have to have these valves throughout them, one-way valves that keep blood flowing only in the right direction. Part of how your veins get blood back is just you moving your body. When you move your arm, it kind of squeezes your veins, and that squeezing pressure just keeps the blood going. That's how low the pressure in the veins is. Whereas in the arteries, lots of pressure. If you cut a vein, blood will kind of leak out. If you cut an artery, blood will gush out. Does that make sense? In fact, if you cut an artery, not only will blood gush out, it'll actually like pulse with your heartbeat. It's under enough pressure that, has anyone ever done that? Ugh. I have not. I've had some cuts. I've never had a major one. You ever seen that like in a movie? I think movies exaggerate it, but I have seen real videos, because I do a thing where I watch surgery videos sometime. And absolutely, when they open up an artery, it does pump with the heart. Pretty crazy. So there we go. So that's all you need to know about kind of the basic system. Not a very exciting presentation. But I want to go through now, and I want to talk about two things. I want to talk about how blood flows, and then I want to talk about the names of the parts. So this, I'm going to draw it. You might also want to draw it. Even if you want to draw it on a whiteboard and take a picture of it, draw it on a piece of paper and take a picture of it. You can try drawing it on your computer if you want, but that can be clunky, right? But I want to draw this, and I want to kind of talk it out, okay? So here's the basic idea. We've got the lungs. What do we get at the lungs again? The whole reason we have lungs is to get oxygen, right? And then we have every cell in your body, right? And every cell in your body needs oxygen. So the question is, how do we take the oxygen that we get in the lungs and get it to every cell in your body? Well, the answer, of course, is your heart, okay? But here's where we're going to do. We're going to just draw your heart like this. And you might as well let me draw it before you start trying yourself, because you'll see everything that needs to be on there. If time permits next week, in addition to doing the fetal pig, we might also dissect a sheep's heart, a nice big one. If we don't get to do that next week, we'll do it as a culminating, because it's a really cool dissection. It's a really cool dissection. And it's a fun one to do. It's really neat because you can actually see the parts of the heart that we're learning about now and see what they're really like, and it's really cool. If this were a normal class, we'd do that before the pig dissection, but just time being what it is. But does anyone know how many chambers in your heart? Your heart isn't just one big pump. It's actually close. Some animals have a 3-chambered heart, but we have a 4-chambered heart. So your heart isn't one pump. It's actually 4 pumps. By the way, your heart's the most amazing machine in the world. Imagine building a machine and saying, okay, this thing is going to run nonstop for 80 years, 90 years, 100 years, 110 years, and it's never going to get maintenance, and we're never going to have to change the batteries. We're never going to have to, just think about, we're never going to change the filter in it. Like, humans can't build machines like that. Like, I have a nice car, but a year from now it's going to need work, and a year after that it'll need work. I just had to replace my brakes because they wear down. But here's the heart. It's this amazing pump that just runs for 100 years and just keeps going. Every second, boom, beats. Yeah.
How long can a heart last?
Well, the oldest person is, like, my grandma's 108. She's never had a heart attack. Her heart's never stopped a moment in her life. She's pretty old. But there's some animals that live to be like 150, 180. There's like turtles and stuff, and they have hearts, and their hearts beat their entire life. So for some people, the heart giving out is what ends their lives, but for other people, it's not, right? Like, so their heart's still good, still working when they pass on, which is pretty crazy. In fact, some people pass on, and they are able to donate their heart to someone else. How crazy is that? You can be an organ donor. I'm signed up to be an organ donor. So if I die for some reason, they can actually take my heart out and they can give it to someone else in certain circumstances. You can't have been lying around for too long. So your heart has 4 chambers. Now, I want to mention something, which is when we look at this, you have to imagine, ready for some beautiful art? Here's a person. This is what we call the anatomical position. This is the worst drawing anyone has ever done. I've done some bad drawings in my day, and this is it. This is as bad as it gets. But that's okay. Here's my person. This person looks like they need medical attention. Wow. Okay. I am ashamed, but that's all right. That's a head. Oh, I'm so ashamed. Okay. Okay, there we go. Okay. So when we draw their heart, we're looking at this as if we're looking at the person. Does that make sense? Which means, I only mention this because people are always going to make a mistake. What side of the heart is this side? Again, you have to imagine it is on you like this. So when we look at this diagram, even though it's the right side of the diagram, what side of the heart is this? If I'm holding it up to myself like this, it's on this side, and this is my left hand. Does that make sense? So be aware, when you see a diagram of the heart, it's in the anatomical position. It's as if it's on your chest. So, a little weird, but this is the left side, and this is the right side. Does that make sense? Okay, a little weird, right? But whenever you look at an anatomical drawing, you're looking from the front, and just like when you look at me, if I hold up my left hand, to you it looks like I am holding up the hand that is on the right. And if I hold up my right hand, to you it looks like I'm holding up the hand on the... Does that make sense? So whenever you look at a diagram, you have to think of it that way. It's like you're looking at the person. So everything is switched. So here's how it works. If we start at the heart, and first we need to go to the lungs, that blood actually starts here, down at the bottom right. Your heart is basically in the middle of your chest. Some people learn that's on the left. It's not. It's in the middle of your chest. It's right about here. This part right here, the bottom right, is responsible for sending blood up to your lungs. All right? Now, this goes this way. So if blood is leaving the heart, is that an artery or a vein? Leaving the heart. Arteries leave the heart. What comes back to the heart? Veins. So that's an artery. In fact, specifically, it's called the pulmonary artery. Pulmonary means lungs. Artery means leaving the heart. So this leaves the heart, goes to the lungs. Okay, this chamber here is called the right, because it's on the right side of the heart, ventricle. Ventricle. The bottom pumps of the heart are called the ventricles. All right? Now, when the blood gets here, what does it get? It gets oxygen. And now, the blood is going to go down into this side. Now, what side of the heart is this? That was the right. This is the left. And the chambers on top are called the atria. So this is the left atrium. The atrium is what the veins connect to. This is where blood is received, right? Blood comes in here, and it goes down into the bottom. And what are the bottom chambers called? Ventricles. So this one will be called the left ventricle. This is the biggest chamber of the heart, because the right ventricle doesn't have to go very far. It just pumps to the lungs. You see that? The reason people think their heart is on the left side is because the left side of your heart is much bigger, because it has a harder job to do. The right ventricle just pumps up to the lungs. Pretty close, right? Heart is here, lungs are there. That's not a big trip. The left ventricle has to pump blood everywhere. Your pinky toe, tip of your head, your brain, your kneecaps, everywhere. Even itself. The left ventricle actually has to give blood even to the heart itself. What is this?
I know.
You quitter!
Yeah, my gun is too clunky.
It seems clunky.
Yeah.
Can I have it?
No.
Can I use it on some students? I have some students I would like to use the fogger gun on.
Well,
We'll talk.
depending.
We'll talk. I'm recording this right now. I'm joking, of course. I'm not joking. I want to get him good. You raise a good point. How's it going? Well? Nice. So the left ventricle has to send blood where? Everywhere. Every single cell in your body has to get blood from the left ventricle. And then, obviously, there's only one place left on here. Where is that going to come back to? The right.
No, atrium.
Very good. The right atrium. And this schematically is how it all works. All right, so we're going to come up here. We're going to cross there. We're going to say, okay, boom, now we come back in there. And sometimes it helps to think of it this way. I'm going to draw it pink when it has oxygen. When does the blood get oxygen? Come on this diagram, where does the blood get oxygen? Yeah, it has it by the time we're here. Of course, it gets it in the lungs, right? Does that make sense? So by the time we get to the left atrium, the blood has oxygen in it. In the left ventricle, the blood has oxygen in it. It goes down through these arteries, because of course arteries leave the heart, and they delivers oxygen. And then because it's delivering oxygen, I'm going to use, this blue color when it's out of oxygen. Now, after it gives the oxygen to the body, it's out of oxygen. Does that make sense? It's going to come back to the heart, still out of oxygen, still out of oxygen. It's going to go into the right atrium, still out of oxygen. It's going to get pumped down to the right ventricle, still out of oxygen. The ventricle is going to pump it to the lungs. When it gets to the lungs, what's going to happen to the blood? The whole point of going to the lungs is it's going to get oxygen. Now it's going to go back through a vein to the left atrium, down to the left ventricle, get pumped everywhere in the body, get collected by the veins. The veins will bring it back to the heart, it'll go down to the right ventricle. Right ventricle sends it to the lungs where it gets oxygen. Repeat, repeat, repeat. Kind of a figure 8 pattern. Does that make sense? Lungs, heart, body, heart. 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 It's big figure 8. Get oxygen. Give oxygen. Get oxygen. Give oxygen. And in the middle of each of those cycles is the heart. Does that make sense? This diagram, you should be able to draw and reproduce. You got time, right? You got time. I'm going to put it up here. I want to go through and name the specific parts of the heart. In a normal class, I would make you memorize this. In this class, I'm not going to make you memorize this. So that's nice, right? That saves you some work. But I want to talk about the names because you should be able to refer to this diagram and find them, all right? Like when we do our dissections, I'm going to say like, hey, where's the septum? Show me that. And you need to know what that means. You can pull up your note and look. So this is what the heart basically really looks like. Now, we showed it up here as having how many chambers? 1, 2, 3, 4, right? If we look at the actual heart, it's got 4 chambers. I'm just going to show them to you. There's a chamber, that's 1. There's a chamber, that's 2. The third chamber is kind of hidden back here, but there it is. And then the fourth chamber is surrounded by these huge muscles. Look how thick the muscle is here. If we get to the heart dissection, it will blow your mind how thick and muscly the heart walls are on this side. And there's the fourth chamber. Does that make sense? We can see them? Because the tubing is integrated. And so like this is not a chamber. That is leading into this tube. Does that make sense? This isn't another chamber. That's leading into this tube. Does that kind of make sense? All right. So first let's just name the 4 chambers. Now this that looks like the left side is actually the right side. Good. So this top chamber here is the right, what do we call the top chambers again? Remind me, we call the top chambers the what do we call them again? I think you do. It's the right atrium. It's the right atrium. So this is the right atrium, which means the top on the other side is going to be the, very good, left atrium. And then what do we call the bottom chambers? The ventricles. So if we look here, this chamber here is the right ventricle. And that means this chamber here is the left ventricle. Does that make sense? Okay, now blood goes from top to bottom. How do we make sure blood goes the right way? Every time blood leaves a chamber and goes somewhere else, it has to pass through a, what do we call something that only lets blood go one way again? A valve, good. So this name, this is actually really good. What side of the body is this valve on? Okay, so it's the right. And then it connects the atrium to the ventricle, right? So we call it the right atrioventricular valve. Well, that's not a bad name, is it? Like, that's actually an excellent name, isn't it? What does that valve do? It's the right atrioventricular valve. It's on the right side of the heart, and it connects the atrium to the ventricle. This is a rare, well-named thing in science, wouldn't you say? I think so. It has a different name too, but I'm not going to teach that to you. You can look it up. And then, so blood starts in the atrium, it goes down to the ventricle, and then it's going to leave and it's going to go to the lungs. Hey, I drew it up there with just one tube. Why are there 2 tubes here to get to the lungs? Because there's 2 lungs. Oh, you're so good. So don't get stressed about that. This side, what side of the heart is this? Right, so it's the right. Hey, is it arteries or veins that leave the heart? I'm going to say this 6 million times till it's just arteries. Good. And this word pulmonary just means lungs. So this is the right pulmonary artery. Sounds fancy, but really it just means the right artery that goes to the lungs. And honestly, if you called it the right artery that goes to the lungs, I'd be pretty happy. But the word for that is pulmonary. So if that's the right pulmonary artery, what do we call this guy? Very good. The left pulmonary artery. That's not so bad, is it? Okay, then it's going to go to the lungs, right? It's going to do its thing at the lungs. It's going to get oxygen. Now it's going to come back. These tubes bring it back. What kind of tube brings blood back to the heart? A vein. What side of the heart are we on? Where's it coming from? It just went to the lungs. Now it's coming back from the lungs. What's this called? Give me the name. Well, right or left?
Right.
Where's it coming from? We just went to the lungs. Now we're coming back from the lungs. Does that make sense?
Anticipating too much.
That's right. What word means from the lungs? What means lungs?
Pulmonary.
Good. So this is the right pulmonary. And then what kind of tube comes back to the heart? Very good. And since there's two of them, these are the veins. Right pulmonary veins. By the way, one just comes from the top of the lungs, one comes from the bottom of the lungs. Doesn't matter. All right. And if there's one of those on the right, coming from the right lung, obviously there's going to be left pulmonary veins. That's not so bad, is it? So what I want to show you, again, normally I would make you memorize this. But normally we'd have time, right? Normally you'd have days, and I'd quiz you, and I'd quiz you again. This course, I don't really care about that, because it's not really about memorizing it. Even when I do make you memorize it, I don't make you memorize it for the sake of memorizing it. I make you memorize it so it'll help you understand it. So today we're just going to focus on understanding it. So we're going to do more things, but just to recap where we are now. Blood starts out here. If we think of this as our starting point, the atrium. The atrium isn't a pump, it's just a collecting place. I mean, it's a little pump, but a really little one. It's not going to pump it anywhere meaningful. So it's just going to squeeze that blood into the right ventricle. The right ventricle is a good-sized pump. Look how thin the walls are here. Look how relatively thick the walls are here. A lot of muscle here, right? So when this squeezes shut, it pushes the blood up. It pushes the blood out to the lungs. Well, when something leaves, we call it an artery, and pulmonary means lungs, so it just pushes it out through the pulmonary arteries, goes to the lungs, where it's going to get oxygen. When it comes back, now we're coming from the lungs, so those are called pulmonary as well, but now they're coming back to the heart, so these are called pulmonary veins. And they come in, and they collect in the left atrium. The atria collect blood, the ventricles pump blood out. So the left atrium collects the blood. Now it's going to go down into the ventricle. Hey, it's got to go through another valve. Hey, what do you think this valve is called? It's going from the left atrium to the left ventricle. What would you call this valve? Well, what side of the heart's it on? Left. And then over here, what did we call the valve that separated the right atrium from the right ventricle? Good. So what do you think we call this one? Yeah, that's right. The left atrioventricular valve. And again, it sounds really fancy, but it's really not fancy at all. It's actually that's a good name, right? It's descriptive. On the left side of the heart, this separates the atrium from the ventricle. And the left side of the heart is the one that has to do the big beefy work. Right? And again, you're going to have lots of time with this, because from the left ventricle, where does it have to send the blood? It has to send it on the big trip. Every single cell in your body. So look how massive the wall of this left ventricle is. See how big and beefy that is? Seriously, when we dissect the sheep's heart, you'll be like, wow, that's like, it's a meal. By the way, it is a meal. People eat heart. And like the big meaty part of the heart is, oh, I don't mind it. Anyway, you just haven't had it prepared right, but that's a different discussion. I'll cook for you guys sometime. But anyway, look at all that meat. Look at it all. That's all muscle, because this is the big pump. Does that make sense? And if you're going to have a big pump, big massive muscle, you need a big pipe coming out of it. Does that make sense? And this is the last thing we really need to name, is this big pipe is called the aorta. This is like the master artery. This is the one that leads everywhere. So the big artery is called the aorta. These are just arteries, all right, that branch off of it. But the aorta is the master artery. It's the highway. These are all the highway exits. Does that make sense? This is the big pipe of water that comes into your house. This would be the one that goes to your sink. This one goes to your shower. This goes to your toilet. Another one would go to your hose, right? All that. But this is the water pipe that comes into the house. Does that make sense? The aorta is the master artery. Now, to get to the aorta, we need to make sure that the blood only goes one way, so we need to go through another. What do we call these things? We need to go through another valve. And again, this one has a good name. It's called the aortic valve. That makes sense, right? It's the valve that makes sure blood can go into the aorta, but it can't accidentally fall back. That's our diagram of the heart. Not so bad. By the way, this diagram here just goes to show, listen, this one you really don't need to know, though I would normally make you memorize it, but just to show you, when we said this is like the master artery, these are called the cardiac arteries, which, don't worry about them, but these actually supply the heart with its own blood. This big muscle, it needs a lot of blood. It doesn't get it from inside the heart. It actually has arteries on the outside that feed it, the cardiac arteries. They branch off the master artery. You can feel this artery. Is this on the left or the right side of the heart? Good. You can feel this. Put your finger about 10 centimeters below your left ear, and you should feel a pulsing. Try it. You should feel your pulse. About a little bit below your left ear. You might have to push around. Don't push too hard, and you'll feel a slight pulse. You got it? You're feeling this artery. Does anyone know what that one's called? Your carotid artery. You ever heard that before? You don't have to worry about it. But the carotid artery is the one that goes up the left. And this is your left carotid. So this, of course, must be your very good. That's your right carotid. And this is called the brachial artery. That just means arm. Brachial, literally, if you spoke Latin, brachus just means arm. So literally, your head artery and your arm artery. This one goes down here, under your collarbone. And then on this side, again, this is the left. And what do you have over here? The right brachial artery. There is kind of a funny thing that the right ones start out as a single tube. Again, you don't have to have these memorized. I care more about the one above, but just to show you, this is actually called the brachiocephalic artery. What? Sounds fancy, but it really means the head and arm artery. If you spoke Latin, nothing in science would be hard, because everything just means like this literally means, this means big tube. Coming off the big tube, we have the head and arm tube, which branches off to the arm tube and the head tube. And over here we got the other head tube and the other arm tube. See, not fancy at all, right? But you're saying brachial and brachiocephalic and carotid. It sounds really fancy. None of these words are fancy. They just mean, artery just means tube, and carotid means neck. And brachial means arm. Neck tube, arm tube. And this is literally the head and arm tube. That's it. That's all those mean. If there's a master artery, there must also be a master vein. And that's this one here, which actually, we have one on top. That comes from your shoulders and head. And we have one below. That comes from your abdomen and your legs. These are the same thing. It's called the vena cava.
Isn't it
It is. That's true. I was going to get to that in a minute. So the vena cava is the master vein. It literally means the cavernous vein. In other words, it's just really big. Yeah, this is literally called the really big vein. And this one's on top. The word for on top is your superior. If someone's above you in life, they're your superior. And if somebody's below you, they are your, I guess. Do you know this word? Inferior. Yeah. So that's the heart. There's a lot going on there, right? Do you have to have this memorized? No. Look at me. You do not. And if I was going to make you memorize it, we would spend days on it. We'd talk about it a lot. We'd dissect it. We'd look at the model. We'd take the plastic out. I'd have you build models of it. Sometimes we do that with plasticine. We really get into it. So do I expect you just to look at this and memorize it? Absolutely not. But if I talk about a part of the heart, do I expect you to be able to pull up this drawing and find that part of the heart? Yes. Does that make sense? So don't spend your time trying to memorize it. You don't have to. It might be interesting to you. You might want to. But more importantly is to understand it. And that's what we're here for. All right? So I'm going to leave this up. You can, if you need to move to a different place in it, you can come here and do that. But it's here for you to work with. All right? There's a few questions about that.